Hi, welcome to the second part of the Threetom modular documentary. Today we're having a look at his audio laboratory where he will calibrate and quality control a freshly built MS-22. Threetom modular, or Tom, is an engineer by day and an engineer by night who designs boutique synthesizer modules for the EURORACK environment. If you haven't seen part 1 of the documentary where Tom assembles a few filter modules while we talk about several things, including his background and his favorite tools, I encourage you to watch that video as well. A link to that video should pop up somewhere here, but I'll put the link in the description box as well. In today's video we talk a little bit about Tom's diagnostic tools. We talk about Tom's recent endeavors with retailers. We also talk about the next module in Threetom's modular lineup called Doppio. And he also shares with us a few subjects that are interesting to have a look into if you're interested in designing and building your own EURORACK modules. But of course we get sidetracked a lot by just several interesting topics. Let's have a watch. Here we are again at the workspace of Tom. Thanks again for welcoming us.
Yeah, welcome back.
Thanks. And what do you have in store for us today?
I just finished 10 modules.
Okay.
So these are part of the batch going to Elevator Sound soon, which has been recently announced that those can be pre-ordered.
Nice.
Kind of expecting that will not last very long.
Yeah.
And so I did this before lunch today, and we still need to pop on the knobs, and then we can go to my little lab upstairs, and we can calibrate them, test them, and hopefully clear them okay for shipping.
Yeah. To see if you did a good job or not.
Yes, and if not, then we'll find ourselves back here to fix things.
Okay. Yeah, let's do it.
All right. So here we are in my tiny lab.
Yeah. Quite impressive.
Yeah, because it's so full.
Yeah, maybe.
So yeah, this place is 2 by 2 meters, and that's about it.
It's very cozy, Tom.
Let me maybe tell you a bit about what's up here before we move on to the testing.
Okay.
So this thing over here is the pride of my lab. It's a Rode and Schwarz audio analyzer. And so it is very good at characterizing properties of audio systems, like signal to noise ratio, frequency transfer curves, stuff like that.
But it's not a scope.
It's not a scope. I also have a scope. So the difference between an oscilloscope and an audio analyzer. So there's 3 main differences. So first of all is bandwidth. Oscilloscopes can have much wider bandwidths, up to a few gigahertz.
Yeah.
And so you asked me earlier why that is important. So let's say you're making something with an Arduino or with a Raspberry Pi or whatever. Yeah. And let's say in case of the Arduino, the clock of the microcontroller is 16 megahertz. Yeah. And that's a square wave.
Yes.
And so the bandwidth is for sine waves. And there's a rule of thumb saying that if you want to see the square wave, you need at least 5 harmonics of the base frequency.
Okay.
So 16
higher.
Becomes 80.
Yeah.
Yeah, 80 megahertz. And so if I have a bandwidth of 80 megahertz, I will be able to see this clock of square clock of 16 megahertz adequately.
So it's not necessarily for audio signals.
No.
Okay.
When I'm using my scope, it's usually for embedded systems. So my scope, for example, can also decode communication protocols between chips and stuff like that. So for that kind of stuff, it's extremely handy if you're working on a system like that. And for general visualization, I use it as well. So LFOs and slow behavior over time. Now, what makes a scope, a digital scope at least, less useful for audio is that the resolution is very limited. It's only 8 bits.
Yes.
Because of the limited resolution, you can only dig so deep into the audio characteristics. And typically, audio performance is found in tiny details of very small amplitudes of stuff that shouldn't be there. And so for truly characterizing audio systems, an oscilloscope is not really
the perfect tool.
For general testing, absolutely. But for audio quality, maybe not.
So even a high-end scope, a digital one, isn't really up to that task.
For assessing audio quality, no.
Not.
And then what the audio analyzer also has over the oscilloscope is that it's really developed for doing audio stuff. So by default, displays are in decibels. The frequency plots are logarithmic, which makes a lot more sense in an audio context. But you will never find an oscilloscope where you can have the frequency stuff plotted on a logarithmic scale.
No.
At least not a scope I can afford in any case. Then what this guy also does very well is a so-called chirp measurement. So it's called that way because the input it sends to a system under test sounds a bit like a bird chirping, and that way it can measure frequency transfer curves, and so which you will see with the filter. Very, very fast, in a fraction of a second. Whereas if you're measuring that kind of thing in the traditional way, it takes seconds or minutes.
And it's just a really fast signal that gets analyzed. Okay.
So then on the other side of the bench, there's a signal generator and a power supply.
The things that Heinbach uses to make music.
Yes.
Oh, but it's a new one.
Nothing that, so this is quite a bit more modern than what Heinbach would use. I did once try to use this, well, no, not this guy, but another more recent generator to do the Heinbach thing, but unfortunately I'm not Heinbach.
I think none of us are.
And then so the power supply and these cables are routed down to my test rack here.
Yes.
And then I have a cable coming out here with which I can power a module under test.
It's just power cable.
So, but what is very nice about this kind of supply is that it has current limits, voltage limits. So should one of my modules, this happens almost never, but still, should there be a hard short circuit on the power supply, then the power supply will detect it before it can cause any harm and shut off.
Just sounds like something that would make a lot of sense in everyone's EURORACK systems, but it's probably a little bit expensive.
They're not super cheap. This is there's two models, and the main difference is the resolution with which you can read back the current draw and the voltage that's at the outputs. And this is the more expensive version, and it costs around 600 euros. The cheaper one is 400-ish, I think.
Relatively affordable, maybe.
This is a Chinese brand, but they've been around for a while, so they're good value for money, typically. Their lower end oscilloscopes are also quite good value for money.
Okay.
Usually when DIY people ask me, hey, what scope should I look at, then I usually recommend one of the cheaper Rygols.
Okay, I'll try to put some links in the description, just like last time.
Yeah.
For the tools that we're looking at now.
Yeah, I'll give you the type numbers later. I'm gonna grab a module here and we can test it. So some lights start to work, that's normal. So I'm gonna put it in the basic setting, of which I know that something should come through. And now when you look on the screen, so now I'm turning the gain, so that in the band pass I have 0 dB, so no gain.
Yes.
And now you'll already see that it somewhat works. So that peak that you're seeing right now, that's moving right now, that's the low pass filter.
Yeah.
And the other peak is the high pass filter.
With some resonance.
Yeah, and I always give it some resonance, so because it makes the cutoff peaks much clearer to see. And this is actually running through your audio analyzer. So this is the chirp test, and I will enable the speaker of the analyzer for a minute, and then you can hear what it sounds like, the chirp test.
Oh yeah.
And so here on the bottom left, what you're seeing, that's actually the signal in time as a response to the chirp. And that is being decoded into this kind of graph, so that we know what the transfer curve is, the frequency transfer curve. And just to prove that I'm not faking this, I'm gonna increase the resonance a bit. There's the resonance.
That really sounds like an MS-20.
Yeah, so I'll disable this because it gets old really fast. So there's these little trimmers on the side of the module, and they're kind of like a gain and offset module for the knobs. And so what I will do during the calibration process is to adjust them so that the range of the knob corresponds with the full useful range in the audio spectrum.
Yeah, makes sense.
And so I typically start with the high pass knob, but that looks surprisingly okay on the low end. And now I turn it to the far end, and did I calibrate this one already? I already calibrated this one. We're gonna take another one. That one was
far too perfect.
Yeah. Okay, so I hooked up another module. I'm bringing it to 0 dB. So by the way, the thing that's in the calibration guide for the full DIY kits, that kind of shows a way of building something like that in your DAW.
Okay, so that's possible.
It's a bit of a different concept. So in that approach, you put white noise through the filter, which is in the spectrum flat. Mm-hmm. And then if you look at the output of the filter through a spectrum analyzer, then you will see this envelope riding on top of the noise that you put in. And like that you can calibrate it yourself. So I'm gonna look at the high pass filter now, and typically what you see is that if you turn it down, the gain will fall a little bit because of the calibration. And so because of that, I'm going to attenuate the internal gain of the high pass filter a bit until it looks more sane, like this. Then I'm turning it to the far end. It's still attenuating a little bit. Some more. Then I'm turning it towards the far end to see where it will end there. And see, it doesn't completely reach the end of the audio spectrum. Typically I limit this at 30 kilohertz, and because the rest of this curve is you can still hear it. And so what I'm going to do is increase the gain a little bit again, and then shift it towards the right.
Okay.
So I'm first increasing the gain a little bit. So you see it move to the right because of that. But as a result, on the opposite side, you will see the dip in gain. So now I'm going to use the offset trimmer to mitigate that and further move it to the right on the far end side. So now I'm moving the knob to the far end side, and now I'm ending up. So this is perfect.
So that's essentially the goal of the calibration.
So this ensures that the far end of the knob corresponds to the far end of the audio spectrum.
Okay.
And then the near end of the knob corresponds with fully open.
And the slight dip we're seeing at the
left,
that's
a result of the resonance. So if you turn down the resonance, that disappears. See? Because the resonance dies a little bit in the low end. If for this filter at least. So and now the low pass filter is up for calibration, and so you see it's now at the far end, and I can turn it a little bit without the transfer curve moving, and so that's not really desirable.
Okay.
So I'm first going to turn it down, and then you see that it will dive into the immeasurable. So that's also not desirable. Typically I tend to calibrate these so that fully closed at 20 Hertz they're attenuating around minus 40 decibels. So this is a first approach. I'm gonna see how it is at the far end. It's almost perfect, so I think I can just reduce the gain trimmer of the low pass a little bit more, and that we will have arrived. So it's around minus 40. And then now I'm going to the far end. And so when I reach this point, I feel the physical stop of the pot, so I know it's calibrated perfectly.
Okay.
And then one thing, from time to time I do get requests for stereo pairs. And then I do this for two filters at the same time. So the audio analyzer can handle stereo. And then I make sure because of course between filters in the same batch there are some minor calibration differences. And also due to components, in rare cases you see slight deviations of the shape of the transfer curve. And so in that case I tend to mix and match filters.
To find
and then calibrate them together. So now it's calibrated, and now the next step is to test the rest of the functions, and for that I have an LFO set up on my generator here. It's exactly 10 volts peak to peak, so that's what it's spec'd to in my specifications of the module. And 10 hertz, no, 200 millihertz, so it oscillates 5 times per second. No, it oscillates once every 5 seconds. Major difference.
So it's an LFO, right?
So that goes into the FCV, and I'm going to place the low pass filter in a central position, and then bring up the FCV attenuator, and you start to see the response to dance in line with following the LFO. And because it's 10 volt peak to peak, I can verify that the range of the modulation does indeed coincide with the useful range in the audio spectrum.
With the calibration that you just did.
Exactly. So now I will turn on the link switch, and you will see that the high pass filter starts to follow. So this is the 100% link, and this is the 50% link. So you see that the high pass doesn't move as much as in the 100% mode. So that already verifies that high pass works, the modulation of the high pass works, the modulation of the low pass works, that this link switch works. You can also see it in the LEDs, that the circuits are, that those CV monitors are working as supposed to. So then the next step is to turn that off, open the low pass filter, turn off the FCV modulation. Then I will bring the high pass filter to a central setting, and I'm gonna use the ACV to modulate it. And so now you see that the high pass peak, the cutoff, is following the LFO.
Yeah.
And now I can also flip it with the polarity of that with a switch. And so when it goes that way and I switch it here, then it will immediately go that way again. So I'm gonna do that now, and click. And so I know that this switch of the modulation matrix works. Now I'm gonna, this CV is normal to the ACV, which is modulating this. So now I'm gonna put it in the other jack to make sure that it's working as well. And then so it keeps on working, so that's okay. Now I'm gonna apply this to resonance, and so you see the resonance being modulated and going into self-resonant mayhem.
That's a nice chaotic mess.
And then the same thing with the modulation switch. I try the different polarity, and then for gain. And you see when it's when you're overdriving it, you see that here in the shape of the transfer curve being flattened.
Yeah, it gets a little bit squashed.
Yeah, exactly. So then now I know that this one is okay.
Yeah,
and
so
it gets the quality control.
Let me try to get those in. Just shimmery, nice.
So now it goes on the back of the module, and power gets turned off. And then I start calibrating the next one. And that's basically it. So this gets repeated for each module. And then so in case an issue does become apparent during this process, I save it for later. I put them in a batch, and then I go back down to the workshop to...
the bad batch.
Yeah, to figure out what's wrong. And typically that's just a soldering point that was either cold or not really that great.
Yeah.
And from that I can also say to all the people who have a challenging build, let's say, that 99% of cases is solder joints. If there's something not working, 99% of the case, 99% of the time it's a dead solder joint or a bad contact somewhere. It is extremely rare that there's something with the boards or the chips on them themselves. It also confirms that typically, well, no process is perfect, of course, and typically where humans are involved, so me, there is the largest likelihood of something that went wrong.
Yeah. I don't know if you want to disclose any numbers, but like what percentage of modules that you built yourself end up in that box with the other bad ones?
Well, I think overall, I think there's about 5 to 10% that need rework, as that is called.
But that's just then, like you said, the solder joints.
Yeah, that's usually just going back downstairs, putting it under the microscope and looking typically at the connectors.
Okay.
And then heating a solder joint or adding some more solder, and then usually they're okay after
fixed.
that. And there's about 1% that is scrapped and recycled for parts.
Okay. That's the calibration and quality control done?
Yes.
Okay, that's...
And then typically what is the next step is to print labels, basically. So that's something I do myself as well. So a really good tip for small manufacturers who are printing their own labels is Affinity Publisher. So it's a piece of software. It's a really nice suite. So basically it's a copy of a few Adobe products, but you don't have to pay a monthly fee to access them. So it's a buy once, cry once situation, and even then it's not super expensive. Currently it's like €100 for the 3 pieces of software in a bundle.
Ridiculously cheap,
yes.
I think, yeah.
And so what that allows you to do is take a spreadsheet like from Excel or Google Docs with information of your modules, and then generate personalized labels.
Yeah.
So with serial numbers, for example. And that allows me to easily print labels with the serial numbers on them.
I never thought about that, actually.
Yeah, you can also use it for many other things, but this kind of thing has been a lifesaver for me.
Yeah, of course.
Because that in the past I used to the field with the serial number was empty, and the customer's name was empty, and I would write that on there with Sharpie.
Which is also a nice touch.
Which is also nice, but it ended up taking a lot of time in the end.
So, Tom, you told me earlier that you're working on a shipment for elevator sound, and I know you did a big shipment for Perfect Circuit as well. Yeah. And that's something new that you're working with retailers?
Yes. So, because the demand for the MS-20 is so high, I wasn't getting through my waiting list to start with. But I also found that I actually spent a lot of time making parcels and shipping them for each individual module. For European customers, that isn't really that much of a problem. It's just print. You have making the label is easy for European customers, but then you still have to make the parcel, which also takes a bit of time because I don't just throw it in there. I tend to make my parcels with care.
You use very nice packaging material, by the way.
Thanks. But then for customers outside of the European Union, there's customs declarations, and those are all kinds of fun. And even though quite a bit of that process is automated through my little web shop, still it requires some manual input. UPS, the lovely people of UPS require you to print the custom declaration and the invoice in triplicate, so 3 times. Very great for the environment. You have to print that 3 times. That has to go into a doculop, which has to go in addition to the label onto the package. So I think making one parcel takes around 20 minutes if you take into account creating the labels and customs declarations and whatnot.
Yeah, if I sell something like a second-hand module and it has to go, I don't know, to Slovakia or something, it's already some work. But so I can imagine if it has to go to the US, that it takes a lot of time.
Yeah. So I thought that maybe if I have a few retailers helping me taking care of that kind of stuff, I can build a few modules extra. Yeah. And then focus on doing the thing that I'm good at. So I think Perfect Circuit and Elevator Sound looks like they're nice collaborations. So I'm looking forward to see how that will evolve further.
Yeah. Is anything changing for people that want to buy the MS-20 too?
Mainly the shipping costs will be less.
Okay.
Because Belgium is ridiculously expensive to ship from.
Yeah.
People who have ordered from me will know that my shipping prices are not great. Regrettably so. I wish I could offer them better prices. For example, to ship a module with UPS to the States is typically 35 euros.
Oof.
For the environment, it's actually a lot better that I ship a whole batch to the guys at Perfect Circuit and they distribute
of course
from there, rather than me making 20 parcels and shipping them by plane to the States.
Yeah. So that's a nice experience.
Yeah, I think it's the next logical step.
And are you thinking about taking that step with European retailers?
So that's the nice thing about Elevator Sound. They both have a UK shop and a European shop. And so by working with them, I have both those markets covered. So people in the UK and in the EU can easily buy from them and normally should have sane shipping rates.
That's good news.
Well,
for you and
I think it's a win for everybody involved, and that also frees up more time for me to either make MS-22s or release the next product.
We talked a little bit about that, but off camera. Can you tell us something about the upcoming module of Threetom modular?
How about take a quick break and I fetch the prototype?
Perfect.
All right?
Yeah. You brought us I don't know if it's the final prototype, but
the almost final prototype.
Okay, and this is the next module in your lineup?
Yes, it's almost finished, so there's still a few minor changes that need to happen.
Okay.
But yeah, I will get to this once I'm done manufacturing MS-22s.
Okay, and what kind of a module is it? I see it's 4 HP, but can you tell us something about it?
This is a 4 HP stereo amplifier and drive module. I found that I needed this kind of circuit for another idea that I've been working on in the past.
Mm-hmm.
And I've actually found that this circuit in its own right was very interesting and very useful to be released as its own entity. And for that reason, I decided to put it into a module of its own.
And it's not just a volume knob, it does more?
Yes, so there's two knobs, gain and volume. And it does that over two channels, either A and B or left and right, depending on how you like to name those things. So as with other linear amplifier modules, you can select the gain, so plus 20 dB or plus 12 dB with this switch here. On top of that, so a normal amplifier, if you drive it too hard, it runs into the supply rails and you will get hard clipping.
Yes.
So that's not very desirable. Also for stereo, if you have complex samples and stuff like that, hard clipping typically isn't very nice.
No, it's not.
And so for that reason, I added two flavors of soft clipping that you can enable on this circuit. And one is more dynamic, that's called drive. Here with this switch you can select it. And then there's a harder kind of soft clipping that I've called limit. And so the more dynamic kind is kind of nice for instruments, instrumental sounds. And the limit is interesting to put it at the end of your chain, so you can use it as a limiter.
Yeah, and depending on the gain setting, I presume that the drive setting reacts differently.
Actually, the setting of drive or limit determines the gain slope once it's past the clipping point.
Okay.
Yeah.
And the plus 20 dB, was it?
Yeah.
Is it to get line level signals? Because EURORACK signals are usually very loud compared to just the output of an electric piano or something. Is it to bring those signals into the EURORACK environment, or?
Strictly speaking, you can do that, but you should keep in mind that this is not a DI box, and so this does not prevent ground loops. So I'm guessing if you're gonna use a battery-powered device, that should turn out pretty okay. If it's another device that's powered somewhere off of your power net, it may not be. I haven't tried so myself.
But it's not designed for that. It's really just to provide plenty amounts of drive.
Yes, and amplification. For example, there's a few samplers out in the EURORACK universe that and typically these kind of samplers, like what's the one from Tom Whitwell called again, the radio music.
Radio music
has a very cool module.
Yeah,
but the output is rather low. At least mine is.
I've heard that before.
And so typically you use an amplifier module to fix that. But if you clip it, then speech samples or old recordings, they're gonna sound pretty harsh.
Yeah.
And so this soft clipping really is a nice way to have it saturated, but not in an ugly way. So it will make it louder, warmer, but not harsh.
Yeah. So it's not necessarily, well, when I looked at the module, I thought, that's end of chain kind of thing to put this module behind the mixer, maybe even behind the compressor, to control the level and the overall saturation. But I can see that you could use it in different ways, as with all things modular, of course. Yeah,
so I think that this is gonna be really nice as a combination with a module like Morphogene, for example. Where that you can further saturate what's coming out without making it sound distorted. Which makes it kind of atypical for a EURORACK module, because typically in EURORACK stuff is aimed towards the distorted. And so I saw that a simple amplifier, a clean amplifier, does not exist for stereo, and neither is there a kind of soft drive, so I thought that this was something that was missing. And that's why I decided to move it towards release. The noise floor is also quite low, even at plus 20 dB of gain. So that is also not always the case in EURORACK. And there's also these cool indicator lights in the coffee beans that will tell you when it's actually soft clipping or hard clipping. So those are also useful.
And again, that's using the translucent PCB material that we talked about last time.
I can probably show you.
So those are the lights on, what's it called, the module?
The module is called Doppio. And so the reasoning behind that is because it is not overly present, but a definite improvement to your sound. Doppio is to your snare what an espresso is to your Monday. It makes it less shitty. And so you see currently it's in the linear mode. So the red LEDs still light up, so that means it's hard clipping.
Okay.
When I put it in limit mode, you will see that they won't reach the red stage again, because the limiting function is keeping that from happening.
And that's independent of what volume you set it at?
Yeah, so that's influenced by the gain. So if I turn down the gain, you will see the lights respond.
Yeah.
And then the output volume is an attenuator for the gained signal. So you can use that to send that to a place where non-EURORACK levels are useful.
Yeah. It's very interesting.
It's perhaps a bit of an atypical or maybe unsexy module. But
maybe.
Yeah, I don't know. But
I don't know what's sexy these days, so yeah.
It's very subjective. But I do think that this will fill a space where there isn't anything yet for the moment.
Yeah, the first time you told me about this, I really thought, this makes complete sense, because indeed there's a lot of distortion or wave shaping kind of focus, and maybe a little bit less on those subjective words like warmth and organic feeling things. So far, my goal here was, to a certain extent, that if you turn this on and keep on cranking it, it shouldn't be overly noticeable that it's there. And of course you're gonna notice an increase in volume, but your sound will still be recognizable, although it's fuller, fatter, whatever you want to call it. And then when you turn it off, the goal was, if you switch back to the dry signal, that you'd be like, no, it's better before. Yeah. So barely noticeable, but
like a good compressor.
Yeah.
But way less complex.
Yeah.
And in stereo.
Yeah, the fact that it can do stereo is very good, because I have like one module that's maybe a little bit like this in my rack, with all kinds of different saturation responses, but it's mono. If I would want to use it as an end of chain module, it's not possible. So I think that makes a lot of sense.
And on the flip side, you can use a stereo module in mono. So there will be... So this is not the case in this prototype yet. On the panel it's already indicated, but if you don't plug in the second input, the output of the first channel will be normaled to the input of the second channel. And like that you get a two-stage soft drive circuit, with then up to 40 decibels of gain.
That's a lot of gain.
Yeah. I'm also... I still have to try this, but I'm thinking that for external instrument inputs, this may also be very nice. So I have downstairs I have the Bufaco instrument interface.
Yeah.
But I find that with my bass guitar, for example, that instrument is super dynamic. So either I have to choose between not clipping and sounding full.
Yes.
And that's kind of putting me off from actually using it that way. So I'm hoping, and I still have to try this out, that if I put this behind the instrument interface and then use that one at a low gain, and use this one at higher gain and have it saturate, that it will make my bass guitar a lot more playable in EURORACK context. And then, of course, on a drum bus, from all the people who've tested it, I hear that they love it on their drum bus.
I was wondering how much power does it draw, because I'm always thinking that modules that offer gain and saturation draw a lot of power, but maybe that's not the case.
That's not necessarily true. So the Doppio consumes up to 45, let's say 50 milliamps on each rail. but that power consumption is actually mostly due to the indicator LEDs because they're very bright and stereo.
Okay.
Because if I turn down the gain, and so that disables the indicator lights, you see that it drops down to 20 milliamps.
Yeah.
And that's the standby current of the module.
Yeah.
Then if you have it drive,
now
it goes
the LEDs
up
are
to 50. So when all the LEDs are on, it's 50 milliamps on each rail. So this is timed after exactly 25 seconds. We take the cup out from under it. It's also because this machine goes through a cycle. You cannot stop it, so the coffee keeps on coming.
Yeah.
But after this point, it's not that nice anymore.
Okay.
All the interesting flavors are in the cup in the first 25 seconds.
Okay. Thank you, Tom, for the nice cup
Cheers.
of... is it a shame to call this just a cup of coffee? Should I call it something else?
A cappuccino.
A cappuccino. Thank you very much. Something that I wanted to ask, I'm sure a lot of people will be interested in this. If anyone wants to get into building EURORACK modules, maybe DIY or even like designing them yourselves, like you are doing, if there's any book that's a must to read or courses to take.
There's unfortunately no shortcuts. Well, building DIY modules, I think that's a good start in any case, buying kits from Exploding Shed or Tonk. Especially if you look very well, or what you should look for in a DIY module, if you want to learn something, is you need to check how much of the design is public, and so that if you want to learn more, you can have a look at the schematic itself. But yeah, the older Befaco modules are great. Also, the North Coast synthesis modules are especially great in that regard. At some point in the past, I built the middle part VCO, and that comes with like an essay of 50 pages describing how the circuit works step by step, with theoretical references, and then it's
that sounds to be interesting indeed.
Yeah, it's very interesting.
So you don't need to backwards engineer something yourself. If all the information is there, that I'm sure that's really useful to learn. And any courses maybe?
So in general, learning about electronics. Maybe let me preface this by saying, so I'm a formally trained engineer, so my answer is going to be biased towards formal training.
Yes.
So I do accept that this is not the only way, but this is the way how I know how to do things. If you look at at the EURORACK scene, there's lots of makers who don't have a formal background in electronics and still manage to be successful and have good products. Tom Whitwell is a prime example. He's a journalist, I believe. And then he has made some of the more influential modules in the
certainly
EURORACK
iconic pieces.
Yeah, I have a few of his modules, and they're very, very enjoyable. That being said, though, I do think that my formal background in electronics has been a major advantage in deciding that I want to build my own modules. So I just did, because I have that background and
you have the training.
I was doing that professionally in a different context anyway.
Yeah.
So designing schematics, making PCBs, that was nothing new to me when I started Threetom. Mm-hmm. That being said, so if you're going to be designing your own analog circuits, digital is a different story. Yeah? I have designed digital systems in the past, and I do think that you can pick up a lot of stuff on the internet about digital design, like stuff with Arduinos and how they can communicate over serial buses with different chips and stuff like that. There's a ton of information out there. Now, analog design is typically more what I would call black magic, because it's not that straightforward, perhaps. It's the basics of analog design are rather mathematical in nature. So the between quotes proper way of learning about this tends to be very boring and dull.
Okay.
So to give you some perspective, so I also, due to strange path in my studies, so I studied electronics for 5 years, and the first 2 to 3 years, that was mainly an abstract thing. I had no fucking clue.
Yeah.
Okay, what am I going to do with these op-amps and transistors?
Yeah.
But because also at that point, I didn't really have a purpose for electronics.
Yeah.
And now, many years later in life, when I decided to start a modular company, that gave me purpose and made me realize, like, that stuff I learned about op-amps and transistors and then resistors and
turns
all
out
those
to be
analog components.
Very interesting.
That is a very useful toolbox that I have now to help me towards achieving my goals. And so to learn about analog electronics, my answer would be you have to learn the theory to some extent first. And there's I can give you a list of topics. So on the top of my head, simple resistive circuits. So how resistors combine. Same thing with capacitors. And so then there's Norton and Thevenin, which allow you to analyze basic circuits. Don't worry about it. Google it. People on YouTube Google Norton and Thevenin. Look it up on Wikipedia. There's the superposition principle, and there is there was one more. Anyway, if you look at Norton and Thevenin and resistor network analysis, that will already give you a good start to understanding simple resistor networks. That really is basic. Of course, you also have to look a bit at LEDs. You'll find plenty of guides for that, how to calculate LED current and stuff like that. And then part of my training was also making amplifiers with transistors and such. But to be honest, I've never really used that part of my training because at that point in time, and certainly now, op-amps are so cheap that's why bother with transistors unless it has a functional reason. Because op-amps are really nice to design with, but in the past they were very expensive, and so people focused on transistors because there was an economical reason for that. So then for working with op-amps, what you have to look at is analysis of simple op-amp circuits. And there mainly the concept of the virtual ground is very important. That's don't worry if that doesn't ring a bell.
All those things sound like amazing sci-fi titles to me. Yeah.
But the concept of virtual ground in analyzing an op-amp circuit is the key to many insights.
Okay.
For example, in op-amps you have an non-inverting amplifier, an inverting amplifier, the inverting buffer, and so those basic kind of circuits. If you understand the virtual ground concept, you're able to fully analyze those circuits and then come up with the formulas for those circuits yourselves.
Okay.
So the virtual ground is the beginning of understanding op-amp circuits. And that is the beginning. And then when you're looking at filters and stuff like that, stuff gets more complex. We got something called complex analysis with imaginary numbers and transfer functions, but in reality that hasn't been super useful. It does give you a feel about the physical concepts behind there, but in practice when designing stuff it's not that useful. Once you understand your basic resistor networks, RC, so resistor capacitor combinations, and op-amp circuits, you should look into simulation software like LT-Spice. I use LT-Spice instead of breadboards. So I design in simulation and then move straight to a prototype. This is a bit atypical. Not everybody does it that way.
I hear a lot of makers use the breadboards, I think, for prototyping.
And that's a valid approach, but for me, the problem with that is documenting what you changed on the breadboard, and then I forget about it because I'm not doing it full time. And so because I'm a bit chaotic in nature, that doesn't work very well for me. Whereas with the simulations, you have to save it before you simulate, and by that you have also documented your work. So in that way, that works very well for me.
Sounds interesting.
So LT-Spice, it's a bit older, but it's free. And there's quite some tutorials and stuff out there. And then there's also this free web app that people use now. Fallstadt. I see a lot of people using that in the DIY community. I don't know if it's really good.
Disclaimer.
But I have the impression that a lot of people are happy with it because it helps them to understand circuits. I've simply never used it in depth because I'm so accustomed to LT-Spice that...
of course, why change when it still works? Okay, that's a lot of useful information. I'll try to link all of that somewhere in the description box as well.
And then that's the schematic part of the story. And then there's still PCB design. So the KiCad is a very nice free package that I also use for designing the Threetom modules. Professionally, I use paying software, but for a small company like me, that doesn't make sense to have paying software in that case, because they're very expensive. Like the one of the industry standards, which is Altium Designer, for example, that costs like 6,000 euros purchase price and a yearly upkeep of 1,500.
Ooh, that's then you need to make some profit to.
And there's other software out there that, for example, Joran uses. Wikipedia will know. Dip trace.
Okay.
Dip trace, you can get a full version. You pay once for a few €100. And a lot of people are happy with it. So I also hear from Joran that he's, I think he's still using that, that he's very pleased with it.
Okay.
And maybe at some point I should change to that as well, but...
Again, why change when it still works? Yeah. Okay.
And then that's the PCB side of things. And then if you want to get really obsessive about it, you can also still look at it from the mechanical design point of view. And then, you need CAD software like FreeCAD is an example, or I use Fusion 360, which is pretty nice. There's also a free version of that with some limitations.
And what do you use that for?
What you can, for example, do, I don't do this in my case, but what you could do is once you've made your design in KiCad, you can export the 3D file of your PCB to Fusion, and then see how all the PCBs fit together in the 3D space.
Okay, makes sense.
But also, for example, in case of Doppio, there is a mechanical design element. So there's a 3D printed light guide. And so that is designed that way to fit over some LEDs and then make contact with the front panel.
Okay.
So there is an aspect of mechanical design to the Doppio, for example.
To prevent too much light leak.
Yeah, so there's no leakage between the indicator lights.
Okay. That's a lot of stuff to...
There's a lot of stuff to learn, and it never stops.
No, but I think that's one of the most beautiful things there are in this field. As a EURORACK user, almost sounds like some kind of addiction, which it maybe is. There's always something to learn.
Engineering is a bit like obsessively walking into a wall and going like, oh damn, that hurt, that was fun, let's do it again.
Let's find out why it hurts. Thank you very much, Tom.
My pleasure.
Thanks
for coming over.
It was a pleasure for me as well. I hope everyone enjoys the content we made together. And I wish you all the best with the release of Doppio. Hopefully we'll see it in a few months.
Yeah, I hope so too.
Yeah.
Unless people keep buying MS-22s.
Oh no. So Tom was so friendly to borrow me, like, what was it called? The polarization filter to mount on top of my lens, so the glare in his glasses are a little bit less. And I just assume that, considering your background as an optical engineer, you know more than me about lenses and cameras in general.
You would think that, but that's not necessarily true.
Okay.
Because in optical engineering, they teach you about the physics of optics and lenses and light and everything. But funnily enough, they don't teach you about photography. So stuff like depth of field and what an aperture practically means related to taking interesting pictures. That's something that's totally not touched upon.
It's completely the technical part of what a lens is, how it works. Do you feel you have some benefit when you are interested in purchasing, I don't know, a lens for a camera or something? Do you have any benefit when you read all the specifications and...
Not really.
No.
Because of a few things. First of all, they don't usually really publish the real technical specs.
Yeah.
So as an optical engineer, if you were really going to, let's say, buy a Nikon lens and going to use that for some kind of scientific application, usually you would like to simulate that lens together with something else that's in your system.
Okay.
But the data to do that is simply not available. Unless you go to high-end custom lenses, which will cost you an arm and a leg.
Yeah.
And so the only thing that from time to time good manufacturers will publish are MTF charts, which tell you something about sharpness of the lens with respect to deviation from the optical axis. But even then, if you read blogs like Ken Rockwell and stuff, you probably know Ken Rockwell.
DP reviews?
Not DP review. KenRockwell.com.
Okay.
And so, very interesting website.
Okay.
Before I buy any lens, I go and read that guy's opinion.
Yeah.
And one of the things he keeps repeating is that, lenses these days are not from the Middle Ages. Most of them are pretty sharp already.
Yeah.
And there's more to a sharp image than purely the lens alone. And there's also some skill involved. So even with a cheap lens, you can get very, very good results, but you have to know how to do it.